Hi class, we're now on 9.4 day 2. Yesterday we talked about direct, joint, and inverse variation. We always used X and Y's and Z's and stuff like that. Now we're doing word problems, so we're going to be using real life situations and applying our equations to them. So just as a review, direct and joint, everything was in the numerator. So for direct, it was y equals k times x. Everything was in the numerator, constant times x. For the joint variation, once again, everything was in the numerator. It was y equals k, and then there was two variables, so k, x, and z. Or there could be 3, 4, or 5. Joint is 2 or more quantities. Inverse was the big one that was different. That's where we had one in the numerator and one in the denominator. So y equals, our constant is in the numerator, and our other variable, oftentimes x, is in the denominator. So those are the three equations that we're going to be dealing with in these next three problems. So for this one, let's identify what we're talking about here. The amount of a person's paycheck P is directly, that word is very important, directly proportional to the number of hours worked H. So our equation, being that it's directly related, we're dealing with this sucker. So instead of using y's and x's, let's use the variables that they give us. The amount of a person's paycheck P is means equals directly proportional, so that means that our k is going to be multiplied by our other variable. Everything is in the numerator. Directly proportional to the number of hours worked H. So it's saying the more hours you work, the more pay you get. The less hours you work, the less pay you get. They have the same direction. Alright, this guy, he works for 17 hours, and guess what he got paid? $90.10. So then this part we're going to do second, find the pay for working 25 hours. Well, first we have to find our constant of variation. So let's do the red information first. So P, which is the price that you earn, $90.10, equals K, our constant of variation, times the amount of hours worked. How many hours were worked? There were 17 of those hours. So let's find our constant of variation. $90, working 17 hours, divide both sides by 17. $90.10 divided by 17, our K is 530. K equals 5.3. Just to put this into perspective for you, class, this is what he earns per hour. $5.30, I might recommend looking for a new job, but if he really likes it, $5.30, more power to him, I guess. So now, if he makes $5.30 an hour, if the price you get paid is 530 times hours worked, how much does he get paid? What is P if he works 25 hours? Well, what is P if 5.3 is multiplied by 25 hours? 5.3 times 25, what is the price that he gets paid? $132.50. Price, $132.50. Once again, class, when you get a price like this, it's all perspective. If it's a job that you do not like and it's very difficult and it's hard work, getting paid $5.30 might not be a great thing to do. However, if I were to get paid $5.30 for just shooting free throws, well, I love playing basketball. I like doing stuff like that, so that might be a good pay for me. So it's all perspective, but he gets paid $132.50. Let's take a look at this next one. The price per person of renting a bus varies inversely. Make sure you read these carefully. That inversely is a big word. It varies inversely with the number of people renting that bus. So that means there is a opposite relationship, which means that the more people that ride the bus, the less each person has to pay. That's what this problem is saying. Let's read it again. The price per person of renting a bus varies inversely with the number of people renting the bus. It costs $13 per person if 66 people rent this bus. How much will it cost per person if 94 people rent the bus? It's kind of like thinking if a bus costs maybe, let's say, $600 to rent. I'm just making up numbers here. Okay? And one person is going to ride that bus. That person has to pay $600. But now, if two people ride the bus, they can split that price and pay $300 apiece. Now, if three people ride that bus, they can each pick up part of that pay, and it would cost them $200 apiece. Can you see how as one quantity increases from 1 to 2 to 3, what happens to the other one? The other one decreases from 600 to 300 to 200, so on and so forth. So this is a very typical example of an inverse relation type problem. Now, enough of Josh Berge's just babbling. Let's start solving this question. It costs $13 per person if 66 people rent the bus. Well, if we're dealing with an inverse variation, we're dealing with y equals k over x. Remember how inverse there's going to be a denominator. K in the numerator, the other variable in the denominator. So let's see. Price per person renting the bus. Our x variable will be the price per person. So that'll be x. And then the number of people renting that bus. Sorry, let's do the y variable right here. The price will be the y variable, and then the number renting, that's going to be our x variable. So it says it costs $13 per person if 66 people rent that bus. So the price is y. Y is $13 per person. Let's find our constant of variation k when x is the number of people renting, which is 66 people renting that bus. So k over 66. And then as we have done in the past, we're going to save this red part until we find our constant of variation. So let's find our constant by multiplying both sides by 66. So 66 times 13, our constant of variation is 858. K equals 858. Okay, if this is the case, if k equals 858, I know that with this equation, y equals k, which is 858 over x. There's our new equation. How much will it cost per person if 94 people rent the bus? Well, the number of people renting the bus, that's our x variable. Find how much it will cost per person. We want to find what y is. So with this equation, what is y if 858 is divided by how many people renting the bus? 94. 858 divided by 94. So y equals 858 divided by 94, which then comes out to be approximately $9.13 per person. Y equals, what did I say? $9.13. And there's that one. So we have done one that has been directly proportional, one that's been inversely proportional. Let's take a look at this one. The amount of oil used by a ship traveling at uniform speed varies jointly, big word, jointly with the distance and the square of the speed. So this ship traveling about, the amount of oil that is used has a relationship that varies jointly with the distance that this ship travels, as well as how fast it goes with the square of the speed. So what it's saying, class, is that the further a ship goes and the faster it goes, as one increases and the other increases, the amount of oil used by that ship increases. They all go up. So with this one, our joint variation is y equals kxz. But let's now start to use some of the variables that maybe we can draw from this. The amount of oil used by a ship, which we'll just call, let's see, O for oil. And I'll do a little doohickey at the top so we don't think it's a zero. So oil, that equals our constant of variation multiplied by, so it varies jointly with what? The distance, so we'll just call that d. And what else? The square of the speed. So we'll use speed squared. Is everyone okay with that? Let's talk about this 1 second. Here's our equation. The amount of oil used by a ship is jointly related to the distance and the square of the speed, or the speed squared. So there is our equation. So now, solving this one through, it says if the ship uses 400 barrels of oil, traveling 500 miles, that's our distance, and 40 miles per hour, there's our speed. With those three, one goes here, one goes here, one goes here, we can now find what our K is, which is what we've done in every single one of these problems. Then once we find our constant of variation, then we can do this part last again. We'll do this part last. Then we can find out how many barrels of oil, so on and so forth, with 400 miles and 20 miles per hour. So, the amount of oil used, there we are, 400 barrels of oil. 400 goes over there. That equals K times the distance. The distance is 500 times the speed squared. So 40 miles per hour is our speed. So 40 squared. You're going to want to take out your calculator for this part. The first thing we're going to do here is we are going to square 40. So that would give us 1600 multiplied by 500 multiplied by K equals 400. So if we multiply 500 times 1600, we get K times 800,000. That equals 400. All right, let's find our constant of variation K by dividing both sides by 800,000. So 400 divided by 800,000, our constant of variation K equals 0.0005. So there's our constant of variation. Whew! Very small number, 0.0005. So using this, now that we know what K is, so maybe we should write this down again. The amount of oil used by a ship is jointly related to the distance times the speed squared. And what did we find out K was? 0.0005. So 0.0005. Okay, now let's go up here. And it says determine how many barrels of oil. So there's our variable that we're going to find. Barrels of oil. This is what we're going to find. When 0.0005 is multiplied by the distance, which is 400 miles, and the speed squared, which is 20 miles per hour. 400 times 20 squared. 400 times the speed, which is 20 squared. All right, so all you have to do is multiply all three of these by each other. So start off with 20 squared. You get 400.0005 times 400 times 20 squared, which is 400. Multiplying these three numbers by each other. How many barrels of oil are used? When I did this in my calculator, I got 80 barrels of oil. And that is how you do problem number 3. Let me know if you have any questions when you see me again tomorrow.